Good morning everyone, and welcome to another video from Grade 9 Science. Today we're going to be looking at where we came from. This is part one of a two-part series, so this is going to look at the Big Bang Theory. And the Big Bang Theory describes what we observe and the empirical evidence we have for where the universe came from about 15 billion years ago. So we're going to talk about two specific things today. One, we're going to discuss what makes up a scientific theory. So you can discuss that. By the end of this, you should know the difference between a scientific theory and, when your grandmother says, I have a theory about that. That's not what we're talking about. We're talking about a scientific theory. And we're also going to be able to, by the end of today, discuss the evidence. We'll discuss what the Big Bang was and discuss the evidence for it. So let's get started. The first question is, what is a scientific theory? And as I said, your grandmother says, I have a theory about why my muffins don't rise properly in the microwave. Anyways, a scientific theory is not just a theory, like your just theory that general people talk about when they make a weak proposal about something. Okay, that's not what we're talking about. We're talking about a scientific theory here, and it's a statement which has been repeatedly supported by multiple strands of evidence and for which there is no evidence to the contrary. Okay, so there's no evidence suggesting that the universe is not expanding. There's no evidence to suggest that, there's no scientific evidence to suggest any scientific theories are incorrect fundamentally, okay? When you do get evidence that a scientific theory is incorrect, then you have what's called a paradigm shift. So we're going to look at the Big Bang Theory today. When we start to discuss theories, or the next two theories we're going to talk about, the Big Bang and the solar nebular theories, which is part two, I'm going to just talk about very, very, very small amounts of it, stuff that's kind of accessible to grade 9 students. There's lots more, but we don't really have time to go into all of it, okay? So the Big Bang Theory says about 15 billion years ago, the universe originated as an extremely hot dot in space, a very, very tiny point, and it expanded from there. And what we're going to do is we're going to go through 4 points of evidence that indicate that this is true. Okay, so let's get started. So 1, this guy, Edwin Hubble, looked out into space with his very large telescope, and he noted a couple of things. He noted that space is expanding. So how do we know that? Well, what we see is light from distant galaxies is red shifted, and that's from what's called the Doppler effect. If a light source is moving away from you, the light becomes slightly more red, or the wavelength becomes longer. If a light source is moving towards you, the light becomes more blue, or the wavelength is shorter. Now this is a very interesting thing, and it's very difficult to see when you're dealing with light. The Doppler effect, when it comes to sound, is actually very easy to understand if you understand that a high-pitched sound has a short wavelength and a low-pitched sound has a long wavelength. Similar to blue light, which has a short wavelength, and red light, which has a longer wavelength. So here's a van. Its horn is blaring. Let's listen to it as it goes by. You can hear at this point the pitch of the horn sound is quite high, which means the wavelength is slightly short. And you can hear as it passes you, the pitch drops and the wavelength becomes longer. And so the same thing happens with a star or a galaxy. As it's coming towards you, the wavelength of the light is shorter and it would be bluer. And if it's moving away from you, the wavelength of the light would be longer and the light would be more red. And so when you look at light and you look into space, you can see the same thing. We know that hydrogen, when you put electricity through hydrogen, as you can see here, in kind of something that's like a neon light. It's not a neon light, of course, it's a hydrogen lamp. It gives off a certain frequency or set of colors. And if you were to put those through a prism, you would see this kind of rainbow. It's not a complete rainbow, but you can see the red here and the blue here. And if your hydrogen lamp isn't moving, you get these wavelengths. don't worry too terribly much about what those wavelengths are or what an NM is. It means nanometers. But if we have another kind of hydrogen lamp, this is a great hydrogen lamp in that it's a cloud of dust and hydrogen and helium. And when we look at the spectrum of hydrogen from this enormous cloud of gas and dust, we see that it's actually red shifted slightly. So as we move along in this series, we can take a look and we can see that the shifting has occurred because the universe is expanding. And we can see this in many, 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 many different galaxies. And so you can see the further away from us, the more shifted the light is from these different galaxies, which is also interesting because it looks like the universe is actually accelerating in its expansion. So first piece of evidence we have for the Big Bang is the universe appears to be expanding as it would from an explosion. So that's one issue. The second issue, and this requires a little bit of math to fully understand, but we're not going to get into the math. You're going to have to trust me on a little bit of this. Using our understanding of nuclear fusion, we have determined that if you took all the matter in the universe and you crushed it down to a single dot, you'd get about 75% hydrogen, and some of it would fuse into helium. And as it cooled out of the expansion from that dot, sorry, there's a typo there, you would get 75% hydrogen and 25% helium. And when we look out into space and we look at the composition of dust and cloud, what we see is it's about 75% hydrogen and 25% helium. We can tell this from the light that those gas clouds are giving off. And like I said, we have those spectral analyses that we know the color that hydrogen gives off, and we know the color that helium gives off. And so we can detect those two different gases just from the light they give off, as they would from a neon lamp. The composition of matter matches perfectly with what we know about hydrogen fusion and helium. This is actually another really interesting piece of evidence, and it's called background cosmic radiation. Back about 60 years ago, there were two gentlemen, I'm just going to skip ahead a slide here, these guys, and they were working at the Bell Laboratories in California, and they had this big, this is actually a very old satellite dish, and they had pointed it to space. And they were getting some feedback. They could hear this feedback. It was like a noise. It was a hiss, and they couldn't figure out what was going on, and they couldn't get rid of it. So they actually got up in here, and they thought maybe the pigeons who were sitting up on the top here were pooping on the telescope, the radio telescope, or the satellite dish, and they were getting noise from that. So they actually shooed all the pigeons away, and they cleaned up all the pigeon poop, and they still had the hiss detector. What we notice is that after an enormous expansion like the Big Bang, there should be some weak energy lying around the universe. And that weak energy should be detected. And it should be about 5 degrees above absolute zero. And so these gentlemen at the Bell Laboratories started to talk about this hissing noise that they were getting. And somebody else said, you know, let's investigate that a little bit more, because that may be background radiation from the Big Bang. And it turns out that if you look around the entire sky that we can see, this background radiation is still out there. And so it's kind of a very, very, very dim light from, you could say, if we're in grade 9, the explosion that happened in the Big Bang. Not exactly correct, but it's a good way to think about it. So this is kind of the radiation that, as the firework that was the expanding universe occurred, this is the last dim light from it. And we can think of it that way. Please don't come back when you go to university and tell me that's wrong. I understand it's wrong. It's more of a model. But this is what we can think of. When we look at the universe, we can see this very dim light everywhere from the Big Bang. And finally, and this is very interesting, when we look back in time, we see that we look into the deep, deep, deep space. And what we find is that the universe has evolved and changed, and it's not static, so it has undergone these changes. When we look at galaxies deep in space that are actually back in time, because it has taken light so many billions of years to reach us because of the expanding universe, we actually see that galaxies were actually a different shape. This scientist called them clumpy and kind of weird. If you look in this is, I believe, a CBC News article. So Hubble's telescope spots galaxies from 13 billion years ago. And we can see these things in there. They're not like galaxies today, so the universe has undergone some very profound evolution as it has moved along. So today we learned 5 main things. The first, a scientific theory is not just a theory. It's not just a whimsical postulation. It's a concrete set of observations for which there is no contrary evidence. And we've learned 4 things about the Big Bang. The universe is expanding. The composition of matter is what we would expect if we had all matter crushed into a single dot. We have background radiation from the explosion of the Big Bang, you could say. And we see that the universe has evolved over time. Okay? So those are our postulates for the Big Bang theory. Thanks for watching.